What's up, mobile devs? I hope you're doing well. In this tutorial, we are going to recreate from scratch this beautiful and simple stacked card spring animation. Of course, we are going to use Reanimated, and the main point of the tutorial will be to explore more in detail how the interpolate function from a Reanimated works. So if you follow my work on Twitter, you probably know that this week I shared a new Patreon animation, which is completely different, but under the hood, it is using the same identical concept. So if you're interested, feel free to check out the animation on Patreon. So before proceeding, I also want to mention that this animation here is highly inspired by a tweet that I saw from Yanum Trivedi. He is making beautiful animations. Unfortunately, he's using SwiftUI, but I highly recommend you to check out his Twitter profile because he creates a lot of tiny UI demos which are really interesting. And last but not least, if you're really curious about React Native animations and want to learn more, don't forget to check out my online course at reanimate.dev. So this course is designed to guide you from the basics of React Native animations to advanced techniques. And let's say the best way to achieve that, in my opinion, is to always recreate something from scratch. Because of that, my tutorials are going to feel just a bit slow, but hopefully they are also going to be very helpful. So this course is definitely built on top of animations, and we are going to explore how Reanimated works, how to unlock the full potential of Gesture Handler, and how to build stunning visual effects with React Native Skia. So no worries at all, because if you want to support me, subscribing to my YouTube channel is definitely more than enough. And that said, let's finally get our hands dirty and let's finally move on to the code part. So here, as you can see, we have our React Native project initialized with Expo. And in this project, I've just installed Reanimated. So we are just going to use Reanimated for this small demo. So that said, I think we can already start to play with the colors. So let's get rid of this text. And instead of using this white, let's use, let's say, some sort of gray, light gray color. So let's get rid of this text and let's define here our card. So we are going to have an array of cards, of course, but for now, let's just focus on the first one. So we are going to have an height equal to 180. Let's say aspect ratio, something like 340. Let's say background color equal to white. Let's add some radius, maybe 25. Border curve equal to continuous. So as always, nothing really changes, honestly. Then let's add also some shadow. So here Copilot is doing everything for me. Thank you. Let's maybe use a different shadow color. And let's add the elevation property for Android, because these ones are not going to work as expected, of course, in Android for now. But who knows, maybe React Native one day is going to support shadows on Android as well, and it will be a great day, honestly. And then let's say, what are we missing? Let's just add the border width and the border color. So here, maybe I think we can use some sort of light gray color as well. And maybe this one is fine. So let's actually extract the style right there, and let's specify here the card style. So let's write styles.card. And to this point, let's try just to map, to iterate over an array of 4 items. So let's say 4. We are going to feed it with the null. Honestly, it doesn't really matter. And we are going to map over the index and define here our cards. So of course, that's quite far from what we are expecting. We want to have all the cards on the same place, and because of that, we need to apply here the position absolute. And there we go. So one additional thing that it is definitely worth doing is trying to rotate all of the cards. So I'm just going to apply some sort of random rotation just to differentiate all of them, because actually by looking at this UI, it seems that we have just one card, but I want to see the potential different cards. So let's make the rotation dependent from the index. So let's do something index multiplied by 10, by 20. So you can see that we have definitely different cards. And actually, let's say, if you look closely, of course, you can see that the order here is not similar to the one that we are expecting. So for instance, we want to see the first card on top, but the point is that since we are mapping and iterating in this specific way with a position absolute, with an absolute positioning, what is happening is that the cards are stacked one on the top of each other. And this means that this one is going to be the card with index equal to 3, this one index equal to 2, index equal to 1, and index equal to 0. So we want to flip the z-index of them. And because of that, instead of using the regular z-index, let's just write minus index. And right now, it starts somehow to make sense. So let's say if we look at the expected result, here we have our lovely pre-recorded demo. And let's say what is happening over there is that the rotation, of course, is not as we are expecting. And for sure, we are missing the effective animation. So the idea to deal with the animation, to deal with this animation, in my opinion, the best way to approach it is to define two different states. The first state, so the initial one, and the last state. And the challenge is to close our eyes and forget completely the animation part and just focus on finding the right values to build this end state and this initial state. So let's focus on the initial state, of course, at first, and let's try to recreate it. So by looking at the UI, somehow it feels that we are not that far, but let's say there is just something wrong with the rotation. The rotation that we have set up is almost right, but let's say we can see that this rotation is flipped in the other direction. So let's just try to add the minus sign. Let's say multiplied by 5, by 20, and actually, let's say, by looking at better, you can see that here maybe 20 is a bit too much. So let's just say 10. And actually 10. Okay. And it seems perfect. So nothing too fancy, honestly. The initial state is pretty simple. So the last state is a bit more tricky. So what you can see is that here it is not just about a rotation, it is also about a translation. So for instance, if we previously rotated the items in the opposite way, in this specific case, we have the item rotated in the opposite ways, but we can definitely see that the translate x, so the x positioning is different and the y positioning is also somehow different. So let's focus on finding the right values. So instead of having so let's say this was the initial state somehow, if we want to keep track of it, let's define here the second state. So actually, let's just copy twice the initial state and let's just update it. So let's say if we reopen it, let's focus on the rotation animation. So you can see that we are rotating in the opposite way. So for sure, we need to remove the minus sign. And let's just say 0 degrees for now. And let's try to recreate this intermediate step. So you can see that we are also, in this specific case, the rotation is almost equal to 0, but we are also applying some translate x. So let's try to apply some translation. And here, let's say, of course, the translation is going to be dependent on the index because it is different for all the cards, and Copilot is always right. And you can see that somehow we are close to it, but let's say we are not interested into recreating the specific frame. We are interested in this one, and in this one you can definitely see that the translate x is a bit higher. And in our specific case, instead of multiplying by 10, we just need to increase it a bit. So let's say 25. And of course, we don't want to have a 0 rotation for the last frame of the animation. We want to have a different rotation. So let's try to play with the values. I mean, of course, it must depend on the index. So let's say index multiplied by something. So let's say I think that somehow this one is correct. So this is the last frame. It looks very similar, but as you can see here, the translate y is slightly different. So we need to apply also a translate y. So let's add here the translate y, and let's say index multiplied by 25. That's a bit too much. So let's say minus, and let's try to see what is happening. And honestly, it looks identical. So I honestly don't remember the perfect values for this demo, but it looks very similar, and I think that it's going to be fine for now. So what we have built so far, we have the initial state, and we have the last state. And the trick is that we just need a way to animate the style from this initial state to this last state. So how can we do that? First of all, let's rewrite actually the transform in a way that it is acceptable for the initial state and for the last state. So let's say such a bad explanation. So let's try to be a bit more practical. Let's just rewrite the initial state, for instance. And let's try here to add what we are missing. So as you can see, the last state contains the translate x, the translate y, and the rotate, but the initial state contains just the rotate. So let's add also there the translate x, and the initial state doesn't have a translate x, so let's just write translate x equal to 0, and translate y equal to 0, because it doesn't have a translate y as well. And here, let's just keep track of what we are expecting. So for instance, here, what I'm expecting is that this translate x is going to become index multiplied by 25. And the translate y, actually the translate x is going to be index multiplied by 25. The translate y will become minus index multiplied by 5. And the rotate is going to shift and become index multiplied by 10 degrees. So that's basically what we want to achieve. So let's remove the last state and the initial state. Let's say so far we didn't do anything, we just reformatted somehow the problem. And what do we need to do? Let's say the best way to deal with that, in my opinion, is to handle, is to get, first of all, a value between 0 and 1, and then use this value 0 and 1 to animate these three different values. So the idea is to have just one value and to animate all of them, which is also quite performant, honestly. So here, sorry, let's try to reload. And there we go. So let's say, how can we get the initial value, the progress value? Of course, we need a shared value. So let's define the progress shared value. So if you're not familiar with the shared value concept, I highly recommend you to check out my full reanimated playlist on YouTube, Or if you're interested too, I have a course about creating React Native animations at reanimate.dev. So let's say the idea is that when we tap on the world view, here for instance, we want to start animating the progress to 1. And when we release the finger, we want to animate back the progress to 0. So we can do that by using, it's not important to have an animated view, by using the onTouch start callback and the onTouch end callback. And there, let's say on the onTouch start, we are going to tap the finger and we want to animate the progress to 1. When we are going to release the finger, we want to animate back the progress to 0. So if we reload and try to tap here, for instance, you can see that it is touched. When I'm going to release, it will be released. And believe me, the progress is changing as well. So what do we need to do? So far, we just need to take this progress and to use the progress inside this view. So since this is a shared value and we want to have an animation, let's say we need to convert this view to an animated view. So let's write animated view and let's actually improve a bit the code. Okay, perfect. I got the parentheses and the first try. That's nice. And the idea is that we want to use this progress over there immediately. So we want to do something like, let's say we want to animate the progress, the translate text by using the progress immediately. We cannot do that instantly, so we cannot write something like progress.value multiplied by index by 25, and this will simply not work. What do we need to do? Let's say if you're familiar with Reanimated, you know that we need to define an animated style. So to define an animated style, we need to use a hook, which is called use animated style. But here, of course, we are going to violate an important rule of React, because we are going to place a hook inside a loop, so inside the map. That's of course not correct, but let's close our eyes for a few minutes and then I swear we are going to fix that. So for now, no worries, because nothing critical is going to happen. So let's just define this style. I mean, this is going to happen, but we're going to reload and everything is going to work nicely. So let's say if we reload, all good. And in the reanimated style, we need to place this transform because we are interested into animating this transform. So let's say transform, and there we go. So here you can see that I have the linting rules. So let's say yes, lint is complaining, but as mentioned previously, let's just close our eyes. So far we have the progress, and if I try to log here the progress, you can see that of course it's logged a lot of times because we have 4 different items. But if I tap here, you can see that we are updating the progress. And the point is that we want that when the progress is equal to 0, the translate x is equal to 0. And when the progress is equal to 1, the translate x is equal to index multiplied by 25. So we can easily convert this condition. Let's say, so let's keep in mind that we can easily convert this condition by writing something like progress.value multiplied by index multiplied by 25. And if the progress is going to be 0, translate x is going to be 0. If the progress is going to be 1, the translate x is going to be equal to index multiplied by 25. And you can see that somehow this is working. Again, for the translate y, we can do something very similar. So we can write something like progress.value multiplied by minus index multiplied by 5. And you can see that the translate y is working properly. So these ones were really simple because the initial, let's say the initial value was 0. So when the progress value is 0, the initial state is going to be 0 and it starts to be very simple. In this specific case, for instance, we have an initial value. So of course we can write the formula, the linear interpolation ourselves and fix this this thing with the, let's say, the proper formula. But let's say, why reinventing the wheel when we have already a solution? And this solution is called interpolate, and it is an amazing function provided by Reanimated to solve exactly this issue. So what do we want to do? Let's try actually to reuse the interpolate function on the translate x and the translate y at first, and let's see how this function works. So first of all, let's define the translate x, and let's import the interpolate function from Reanimated. So the interpolate function accepts a number, the number that we want to interpolate, and the number is going to be the progress, accepts an input range, which let's say it is the range of values that the progress is going to change with. So for instance, the progress is between 0 and 1, so the input range is going to be 0 and 1. And then the output range, so the range that we are expecting for the translate x. And we know that when the progress.value is going to be equal to 0, the translate x needs to be 0. When the progress.value is equal to 1, the translate x needs to be equal to index multiplied by 25. And here, let's say if we paste here the translate x, we are going to see the exact result that we got previously. So we can use the same formula for the translate y as well. So let's say translate y. Let's use the interpolate. So we have the progress.value, we have the input range, and we have the output range, because we are expecting that the translate y value is between 0 and minus index by 5. So let's use here the translate y. And finally, we can define the rotate. So the rotate is going to use the interpolate. We have the progress.value. We know that let's say the progress is between 0 and 1. And the rotation is between, let's say, minus index by 10. So the initial value is going to be minus index by 10. And the last one is going to be index by 10. So here, let's pass the rotate, and let's keep the string interpolation because we want to keep the degrees. And if we try to tap, you can see that everything is working nicely. So let's say for now, the progress.value is 0 or is 1. What if we have the progress.value between 0 and 1? So what if it is right there? Automatically, a linear interpolation is going to be applied, and because of that, the translate x value is going to be linearly interpolated between these values. So this is going to be applied for all the use cases. So what I also want to point out is that keep in mind that here the input range has just 2 values, but you can add as many values as you want, and you can control, you can have a lot of detail over the animation by adding, for instance, intermediate breakpoints. That said, let's finally build the animation, and let's say we did so far the hard work. Right now we just need to apply a with timing transition to 1 and with timing to 0. And by doing that, you can see that automatically the animation is working perfectly. So instead of a timing transition, let's use the spring, which is always better for these specific use cases. And you can see how the animation is working perfectly. If you want to get fancy, you can also add update the mesh property. And you can see how the animation is a bit more bouncy than it should be. So as promised previously, of course, we can't write this code in production. I mean, we can, but let's try to respect the React rules. So how do we solve this issue? Of course, we cannot just ignore the problem. We need somehow to create a new component and reuse this use animated style into a component. So how can we do that? Let's create just card. So let's say React functional component. I'm not going to create a separate file because actually it is very simple. So we just need to copy the code that we have right there. So the code needs the index. So let's say card props. Let's accept the index. And let's say that the card accept the card properties. So let's pass the index. And then we have the reanimated style. So instead of defining the reanimated style inside the array, let's just define it over there. What else? Let's say for each card, we need to access the progress. So let's access the progress right there. And we are going to have a shared value of type number. So the progress is defined with the user shared value. So of course, it is let's say a reanimated shared value. Let's see, progress. And right there, let's just return the card by passing the key as an index, the index as an index, and the progress as a progress. So here, nobody is complaining anymore, fortunately, and the animation is working smoothly. One additional thing that let's say it's worth showing is the fourth parameter of the interpolate function. So as you can see, the interpolate function has an x, which is our progress, the input range, the output range, and the extrapolation type. To be honest, let's say 99% of the times, let's say not 99, 50% of the times, you are not going to place anything over there. So for instance, in this specific case, it's fine. So we are happy with the current result. But in some specific case, for instance, we want to clamp the animation. So for instance, we have a spring transition, and if we actually log the progress right there, you can see that actually the progress is not just between 0 and 1, it is between some minus values and some values greater than 1. So the point is that after all, the input range is between 0 and 1, so we didn't write something like 0.2 or minus 0.02. So how the interpolate function is going to behave when the progress is greater than 1 and less than 0? We are, let's say, we didn't specify anything, so it will use the default from Reanimated, and the default extrapolation type is the extend. So let's assume that we want to clamp, let's say we want to avoid this spring effect. We want to ignore the values that are greater than 1 and less than 0, and we want to enforce them to be always equal to minus index by 10 and index by 10. We can do that by adding the extrapolation clamp. So let's add the extrapolation clamp to all of them. And everything is working perfectly. So as you can see, we are somehow losing the springify effect. But that's just because we are ignoring the bouncing values, so the values that are greater than 1 and less than 0. So from, let's say, my personal experience, 50% of the time you need to use the extrapolation clamp, 50% of the time you can just ignore this value. In this specific case, in my opinion, is great. Let's say it's better to keep the bouncy effect. So, I mean, that's fine. So I really hope that this explanation was clear and this tutorial was enjoyable. If you like this video, of course, feel free to subscribe to the channel. And if you have ideas for upcoming content, feel free to suggest them in this section below. So that said, thanks a lot for staying with me all this time, and hope to see you to the next one.